Introduction of Vedic Maths. The Vedic Mathematics is called so because of its origin from Vedas. To be more specific, it has originated from Atharva Veda or the fourth Veda. Atharva Veda deals with the branches like engineering, mathematics, sculpture, medicine, and all other sciences with which we are today aware of. This wonderful method is reintroduced to the world by Swami Bharati Krishna Tirthaji Maharaj, the Shankaracharya of Govardhan Peeth, Puri. Vedic mathematics was the name given by him. He was the person who collected lost formula from the writings of Atharva Vedas and wrote them in the form of 16 sutras and 13 sub-sutras. Sutra's natural formula. The term Vedic mathematics refers to the unique technique of calculations based on a set of 16 sutras or aphorisms or formulae and their upasutras or corollaries derived from these sutras. Any mathematical problem like algebra, arithmetic, geometry, or trigonometry can be solved mentally with these sutras. Vedic mathematics is more coherent with modern mathematics. The list is so compiled, which contains 16 sutras and 13 sub-sutras. 16 sutras. Ekadhikina purvena Nikilam Navatascharamam dashata Urdhva triyabhyam Parawartya yojayet Shunyam samya samukhe Anurupye shunya manyat Sankalana vyavakalanabhyam Purana puranabhyam Chalana kalanabhyam Yavadunam Vyasti samansti Sheshanyankena charamena Sopantya dvayamantyam Ekanyunena purvena Gunitas samukhya Gunakas samukhya. The 13 sub-sutras. Anurupyena Sisyate Sesha Samjana Adya Mandyentya Mantyanaha Kevalyah Saptakam Gunyat Vestanam Yavadunam Tavadunam Yavadunam Tavadunikritya Vargankayojayet Anteyor Dasakepi Anteyoreva Samukhya Gunita Lopanasta Pandhyam Vilokanam Gunita Samukhya Samukhya Gunita. How Vedic mathematics is different from conventional system. Each system has got its own limitations. Similarly, the conventional system which you are using at present has its limitations too. If you do a lot of practice, then also you will not be able to improve your calculation speed beyond a certain point. Why? The answer is a system that you are using has reached its limitations. But surprisingly, people take it as their limitation. Comparison between Vedic and conventional system. Here we are putting a comparison between conventional method and magical methods for you to have a look. Have a look at this conventional method. In conventional system, you multiply the top digits one by one with the bottom digits and add them to get the answer. Have a look at this magical method. In magical method, you can multiply the numbers directly. The above problem has been done using crisscross technique of Vedic mathematics. Once you have little practice, you can do it straight, which means 28,232 multiplied by 53,246 equals 150 crore 32 lakh 41,072. What is the speciality of Vedic mathematics? Vedic scholars did not use figures for big numbers in their numerical notation. Instead, they preferred to use the Sanskrit alphabets, with each alphabet constituting a number. Several mantras, in fact, denote numbers. That includes the famed Gayatri mantra, which adds to 108 when decoded. How important is speed? How fast you can solve a problem is very important. There is a race against time in all competitions. Only those people having fast calculation ability will be able to win the race. Time saved can be used to solve more problems or used for difficult problems. Uses of Vedic mathematics. It helps a person to solve mathematical problems 10 to 15 times faster. It helps in intelligent guessing. It reduces burden. Need to learn tables only up to 9. It is a magical tool to reduce scratch work and finger counting. It increases concentration. It helps in reducing silly mistakes. Urdhva Tirbhyam. Urdhva Tirbhyam is a general formula applicable to all cases of multiplication and also in the division of a large number by another large number. It means vertically and crosswise. Using vertically and crosswise, you do not need to do the multiplication tables beyond 5 multiplied by 5. Suppose you need 8 multiplied by 7. 8 is 2 below 10 and 7 is 3 below 10. Think of it like this. The answer is 56. The diagram below shows how you get it. You subtract crosswise 8 minus 3 or 7 minus 2 to get 5, the first figure of the answer. And you multiply vertically 2 multiplied with 3 to get 6, which is the last figure of the answer. And that's all to it. Look how easy it becomes. See how far the numbers are below 10. Subtract one number's deficiency from the other number and multiply the deficiencies together. For example, 7 multiplied by 6 equals 42. Here, there is a carry. The 1 in the 12 goes over to make 3 into 4. Here's how to use vertically and crosswise for multiplying numbers close to 100. Suppose you want to multiply 88 by 98. Is that easy? Oh, not so easy. You might think, but with vertically and crosswise, you can give the answer immediately using the same method as above. Both 88 and 98 are close to 100. 88 is 12 below 100 and 98 is 2 below 100. You can imagine the sum set out like this. As before, the 86 comes from subtracting crosswise, which is 88 minus 2, which equals 86, or 98 minus 12, which equals 86. You can subtract either way, you will always get the same answer. And the 24 in the answer is just 12 multiplied by 2. You multiply vertically. So 88 multiplied by 98 equals 8624. Ekadhikena purvena. The sutra Ekadhikena purvena means by one more than the previous one. A quick way to square numbers that end in 5 using the formula by one more than the one before. For instance, 75 square equals 5625. The 75 square means 75 multiplied by 75. The answer is in two parts, 56 and 25. The last part is always 25. The first part is the first number, which is the 7, multiplied by the number 1 more, which is 8. So 7 multiplied by 8 equals 56. Similarly, the 85 square equals 7225 because 8 multiplied by 9 equals 72. For instance, 32 multiplied by 38 equals 1216. Both the numbers here start with 3 and the last figures, that is the 2 and 8, add up to 10. So we just multiply 3 by 4 to get 12 for the first part of the answer, and we multiply the last figures 2 multiplied by 8, which equals 16, to get the last part of the answer diagrammatically. And now 81 multiplied by 89 equals 7209. We put 09 since we need two figures as in all the other examples. Parawatiam yojaye means transpose and apply. Consider the division by divisors of more than one digit, and when the divisors are slightly greater than the powers of 10. For example, divide 1225 by 12. Here, if we take from left to right, write the divisor leaving the first digit, write the other digit or the digits using the negative sign and place them below the divisor as shown. Now, write down the dividend to the right, set apart the last digit for the remainder, and then write the first digit below the horizontal line drawn under the dividend. Multiply the digit by -2 and write the product below the second digit and add. Since 1 multiplied by -2 equals -2 and 2 plus -2 equals 0. Now we get the second digit sum as 0, multiply the second digit sum thus obtained by -2 and write the product under the third digit and add. Finally, continue the process to the last digit. To sum up, the sum of the last digit is a remainder and the result to its left is quotient. Thus, the quotient equals 102 and the remainder being 1. Shunyam Samya Samukhe. The sutra Shunyam Samya Samukhe says the Samukya is the same. That Samukya is 0. That is, it should be equated to 0. The term Samukya has several meanings under different contexts. We interpret Samukya as a term which occurs as a common factor in all the terms concerned and proceed as follows. For example, in the given equation, 7x plus 3x equals 4x plus 5x, which has the same factor x in all the terms. Hence, by the sutra, it is 0. That is, x equals 0. Otherwise, we have to work like this. 7x plus 3x equals 4x plus 5x, which is 10x equals 9x, and 10x minus 9x equals 0. Therefore, x equals 0. This is applicable not only for x but also any such unknown quantity as follows. Anurupye Sunyamanya. The sutra Anurupye Sunyamanya says if one is in ratio, the other one is 0. We use this sutra in solving a special type of simultaneous simple equations in which the coefficients of one variable are in the same ratio to each other as the independent terms are to each other. In such a context, the sutra says the other variable is 0, from which we get two simple equations in the first variable, which is already considered, and of course gives the same value for the variable. For example, 3x plus 7y equals 2 and 4x plus 21y equals 6. Observe that the y coefficients are in the ratio 7:21, which is 1:3, same as the ratio of independent terms, that is 2:6, which is 1:3. Hence, the other variable x equals 0 and 7y equals 2, or 21y equals 6, which gives y equals 2/7. Let's look at another example. 323x plus 147y equals 1615. 969x plus 321y equals 4845. The very appearance of the problem is frightening, but just an observation, and Anurupye Sunyamanya gives the solution x equals 5, because the coefficient of x ratio is 323:969, which equals 1:3, and constant terms ratio is 1615:4845, which again equals 1:3. Y equals 0 and 323x equals 1615, or 969x equals 4845 gives x equals 5. Sankalana Vyavakalanapyam. This sutra means by addition and by subtraction. It can be applied in solving a special type of simultaneous equations where the x coefficient and the y coefficient are found interchanged. For example, 45x minus 23y equals 113, and 23x minus 45y equals 91. In the conventional method, we have to make equal either the coefficient of x or coefficient of y in both the equations. For that, we have to multiply equation 1 by 45 and equation 2 by 23 and subtract to get the value of x, and then substitute the value of x in one of the equations to get the value of y. Or we have to multiply equation 1 by 23 and equation 2 by 45 and then subtract to get the value of y, and then substitute the value of y in one of the equations to get the value of x. Isn't that a difficult process to think of? Whereas from Sankalana Vyavakalanabhyam, add them, that is 45x minus 23y, and add 23x minus 45y to this, which equals 113 plus 91. That is 68x minus 68y, which equals 204. Therefore, x minus y equals 3. Subtract one from the other here, that is 45x minus 23y minus 23x minus 45y, which equals 113 minus 91. That is 22x plus 22y equals 22, and therefore x plus y equals 1. And repeat the same sutra, we get x equals 2 and y equals minus 1. Using the sutra, very simple addition and subtraction are enough, however big the coefficients may be. Multiplying by 12 shortcut. So how does the 12 shortcut work? Let's take a look. 12 multiplied by 7. The first thing is to always multiply the 1 of the 12 by the number we are multiplying by, in this case 7. So 1 multiplied by 7 equals 7. Multiply this 7 by 10, which gives 70. Why? We are working with bases here. Bases are the fundamentals to easy calculations for all multiplication tables. Now, multiply the 7 by the 2 of 12, giving 14. Add this to 70, giving 84. Therefore, 7 multiplied by 12 equals 84. Now let's try another. 17 multiplied by 12. Here, always remember, multiply the 17 by the 1 in 12 and multiply by 10. Just add a 0 to the end. 1 multiplied by 17 equals 17, multiplied by 10 giving 170. You've added a 0 there at the end. Multiply 17 by 2 giving 34. Add 34 to 170 giving 204. So 17 multiplied by 12 equals 204. Let's go to one more example. 24 multiplied by 12. Here, multiply 24 into 1, which equals 24. 24 multiplied by 10, giving 240. Multiply 24 by 2, which equals 48. Add 240 to this, giving us 288. Therefore, 24 multiplied by 12 equals 288. These are seriously simple sums, aren't they? Squared shortcut. Here is a really quick way to square any number with a 5 on the end. Let's take 45 square. Okay, so what you have to do is split up the numbers, giving you 4 and 5 square. Forget about the 5 square for the moment and do this. Always add 1, adding 1 to the 4, so we get 5. Then multiply this answer 5 by the original first number 4, which equals 5 multiplied by 4 equals 20. So what you have is 20 and 5 square. Everyone knows 5 square is 25, right? Well, it does. This is what makes it easy. Put the two answers together and that's the answer. 2025. This works for any number ending in 5 square, but when the numbers get over 100, it tends to get a little trickier with the multiplication. Give it a try with another number. Try 85 square. Isn't it difficult? Split the number apart, 8 and 5 square. Again, forget about the 5 square. Add 1 to 8, which is 9. Multiply 9 by the first number, which is 9 multiplied by 8 equals 72. Now, put all the numbers together, 72 and 5 square. 5 square, we are already aware, is 25. So, the answer is 7225. Try it out in a calculator once you have done it. Decimals, equivalents of fractions. With a little practice, it's not hard to recall the decimal equivalents of fractions up to 10 divided by 11. First, there are 3 you should know already. 1 by 2 or half equals 0.5. 1 by 3 or 1/3 equals 0.333 and so on. 1 by 4 or 1/4 equals 0.25. Starting with the thirds, of which you already know 1, 1/3 equals 0.333 and so on, or 2/3 equals 0.666 and so on. You also know 2 of the fourths as well. So, there's only one new one to learn. 1/4 equals 0.25, 2 by 4, which is equivalent to 1 by 2, which equals 0.5, and 3/4, which equals 0.75. The fifths are very easy. Take the numerator, which is the number on top, double it, and stick a decimal in front of it. 1/5 equals 0.2, 2/5 equals 0.4, 3/5 equals 0.6, and 4/5 equals 0.8. There are only 2 new decimal equivalents to learn with the 6, which is 1/6 equals 0.166 and so on. 2/6 equals 1/3, which is again 0.33 and so on. 3/6, which is again half, which equals 0.5. 4/6, which is 2/3, which again equals 0.66 and so on. And 5/6, which equals 0.8333 and so on. Now, what about the 7ths? Well, we'll come back to them at the end. They are very unique. The 8ths aren't that hard to learn, as they are just smaller steps than the 4ths. If you have trouble with any of the 8ths, find the nearest 4th and add 0.125 if needed. That is, 1/8 equals 0.125, 2/8 equals, which is again 1/4, which is 0.25, 3/8 equals 0.375, 4/8, which is half again, which is again 0.5, 5/8, which equals 0.625, 6/8, which is again 3/4, and it is 0.75, and 7/8, which is 0.875. Now, the 9ths are almost too easy to learn. 1/9 equals 0.111 and so on. 2/9 equals 0.222 and so on. 3/9 similarly equals 0.33 and so on. 4/9 equals 0.444 and so on. 5/9 equals 0.555 and so on. and 6 nines equaling 0.66 and so on, 7 nines equaling 0.77 and the 8 nines which is 0.88 and the like. The tenths are very easy as well. Just put a decimal in front of the numerator, which is 1/10 equals 0.1, 2/10 equals 0.2, 3/10 equals 0.3, 4/10 equals 0.4, 5/10 equals 0.5, 6/10 equals 0.6, 7/10 equals 0.7, 8/10 equaling 0.8 and 9/10 equaling 0.9. Isn't that easy? Remember how easy the nines are. Similarly, the 11s are easy, assuming you know your multiples of 9. For instance, 1/11 equals 0.09 and 09 and 09 and so on. 2/11 equals 0.18, 0.18, 0.18 and so on. 3/11 equaling 0.27, 27 and so on. 4/11 equaling 0.36, 0.36 and 36 alike. 5/11 equaling 0.45, 45 and 45 and 6/11 equaling 0.54, 54, 54 and so on. 7/11 equaling 0.63, 63 and 8/11 equaling 0.72, 72 and 9/11 equals 0.81, 81, 81 and 10/11 equals 0.90, 90 and 90, which is nothing but the multiples of 9. As long as you can remember the pattern for each fraction, it is quite simple to work it out. The decimal place as far as you want and need to go. Oh, I almost forgot. We haven't done the 7th yet, right? Let's get back to the 7th. 1/7 is an interesting number. 1/7 equals a decimal 142857, 142857 and 142857 and so on. For now, just think of 1/7 as decimal followed by 142857. See if you notice any pattern in the 7th. 1/7 equals 0.142857, 2/7 equals 0.285714, 3/7 equaling 0.428571, 4/7 equaling 0.571428 and so on, 5/7 equaling 0.714285 and so on, and 6/7 equaling 0.857142 and so on. Notice here that the 6 digits in the 7th always stays in the same order and the starting digit is the only thing that keeps changing. If you know your multiples of 14 up to 6, it isn't difficult to work out where to begin the decimal number. Now, look at this. For 1/7, think 1 multiplied by 14 giving us 0.14 as the starting point. For 2/7, think 2 multiplied by 14 giving us 0.28. And for 3/7, think 3 multiplied by 14 giving us 0.42 as the starting point. For 4/14, 5/14 and 6/14, you will have to adjust upward by 1. For 4/7, think 4 multiplied by 14 plus 1 giving us 0.57 as the starting point. For 5/7, think 5 multiplied by 14 plus 1 giving us 0.71 as the starting point. For 6/7, think 6 multiplied by 14 plus 1, giving us 0.85 as the starting point. You practice these and you will have the decimal equivalents of everything from 1 by 2 to 10 by 11 at your fingertips. If you want to demonstrate this skill to other people and you know your multiplication tables up to the hundreds for each numbers from 1 to 9, then give them a calculator and ask for a 2-digit number or a 3-digit number if you're up to it to be divided by a 1-digit number. If they give you 96 divided by 7, for instance, you can think, the closest multiple of 7 is 91, which is 13 multiplied by 7 with 5 left over. So, the answer is 13 and 5 by 7 or 13.7142857. Isn't that good? Is it divisible by 4? This little math trick will show you whether a number is divisible by 4 or not. So, this is how it works. Let's look at 1234. Does 4 divide evenly into 1234? For 4 to divide into any number, we have to make sure that the last number is even. If it is an odd number, there is no way it will go in evenly. So, for example, 4 will not go evenly into 1233 or 1235. Now, we know that for 4 to divide evenly into any number, the number has to end with an even number. Let's get back to the question. Does 4 divide into 1234? The solution is, take the last number and add it to 2 times the second last number. If 4 goes evenly into this number, then you know that 4 will go evenly into the whole number. So, 4 plus 2 into 3 equals 10. 4 goes into 10 2 times with a remainder of 2, so it does not go in evenly. Therefore, 4 into 1234 does not go in completely. Let's try 4 into 343,6546 or 34,36,546. So, from our example, take the last number 6 and add it to 2 times the penultimate number 4. 6 plus 2 multiplied by 4 equals 14. 4 goes into 14 3 times with 2 remainder. So, it doesn't go in evenly. Multiplying by 11 shortcut. This technique teaches you how to multiply any number by 11 easily and quickly. We will take a few examples, and from these you will see the pattern used and also how easy they are to do. So, to begin, let's try 12 times 11. First things first, so you will ignore the 11 for the moment and concentrate on the 12. Split the 12 apart like 1 and 2. Add these 2 digits together. 1 plus 2 equals 3. Place the answer 3 in between the 12 to give 132. And therefore, 11 multiplied by 12 equals 132. Let's try another. 48 multiplied by 11. Again, leave the 11 alone for a moment and work with 48. 4 plus 8 equals 12. So now we have to put the 12 in between the 4 and 8, but don't do this. 4, 1, 2, 8 is wrong. First, do this. Place the 2 from the 12 in between the 4 and 8, giving 4, 2, 8. Now, we need to input 1 from the 12 into our answer also, and to do this, just add the 1 from 12 to the 4 of 4, 2, 8, giving 5, 2, 8. Okay, now let's go to one more. 74 multiplied by 11, that is 7 plus 4 equals 11. Now, the 7, put 1 from right of 11 in 7 and 4. Then add 1 from the left of 11 to this 7, which is 74 multiplied by 11 equals 814. This is a really simple method and will save you so much time with your 11 times table. Converting kilometers to miles. This is a useful method for when traveling between imperial and metric countries. You need to know what kilometers to miles are. The formula to convert kilometers to miles is the number of kilometers divided by 8 multiplied by 5. So let's try 80 kilometers into miles. 80 by 8 equals 10, multiplied by 5 equals 50 miles. Now let's go to another example. 40 kilometers is 40 by 8, which equals 5, and 5 multiplied by 5 equals 25 miles. Isn't that easy? Multiplication using all from 9 and the last from 10. There are many applications of the all from 9 sutra, the first of which has to do with multiplying two numbers together. Suppose we have to multiply 8 by 9, we should take 10 as the base for the calculation, which is the next power of 10 above the two numbers. The two numbers are set down as shown here, and the complements from the base 10 are written in Vedic Mathematics, which was developed as a system derived from Vedic principles by Swami Bharati Krishna Tirthaji in the early decades of the 20th century. A few opinions are stated here. Mathematics derived from the Veda provides one-line, mental and superfast methods along with quick cross-checking systems. Vedic mathematics converts a tedious subject into a playful and blissful one which students learn with smiles. Vedic mathematics offers a new and entirely different approach to the study of mathematics based on pattern recognition. It allows for constant expression of a student's creativity and is found to be easier to learn. In this system, for any problem, there is always one general technique applicable to all cases and also a number of special pattern problems. The element of choice and flexibility at each stage keeps the mind lively and alert to develop clarity of thought and intuition, and thereby a holistic development of the human brain automatically takes place. Vedic mathematics, with its special features, has the inbuilt potential to solve the psychological problem of mathematics. J.T. Glover says that the experience of teaching Vedic mathematic methods to children has shown that a high degree of mathematical ability can be attained from an early stage while the subject is enjoyed for its own merits. A.P. Nicholas puts the Vedic mathematics system as one of the most delightful chapters of the 20th century mathematical history. Professor R.C. Gupta says, the system has great educational value because the sutras contain techniques for performing some elementary mathematical operations in simple ways, and results are obtained quickly. Professor Jain Kapoor says, Vedic mathematics can be used to remove math phobia and can be taught to school children as enrichment material along with other high-speed methods. Dr. Michael Wainless, chairman of the Department of Mathematics, Iowa, says that Vedic mathematics is easier to learn, faster to use, and less prone to error than conventional methods. Further, the techniques of Vedic mathematics not only enable the students to solve specific mathematical problems, they also develop creativity, logical thinking, and intuition. Keeping the above observations in view, let us enter Vedic mathematics as given by Sri Bharti Krishna Tirthaji, the Shankaracharya of Govardhana Mutt, Puri. Entering into the methods and procedures, one can realize the importance and applicability of the different formula and conclusion. After going through the content presented in this CD, you may, perhaps, have noted a number of applications of methods of Vedic mathematics. We are aware that this attempt is only to make you familiar with a few special methods. The methods discussed and organizing of the content are intended for any reader with some basic mathematical background. That's why the serious mathematical issues, higher level mathematical problems are not taken up in this volume, even though many aspects like 4 fundamental operations, squaring, cubing, linear equations, simultaneous equations, factorization, HCF, recurring decimals are dealt with. Many more concepts and aspects are omitted unavoidably, keeping in view the scope and limitations of the present volume. The Vedic methods enable the practitioner improve the mental abilities to solve difficult problems with high speed and accuracy.